Welcome to lesson 3.3, using square roots to solve quadratic equations. So, when b equals 0, the equation ax squared plus bx plus c equals 0, where a cannot equal 0, becomes ax squared plus c equals 0. If this equation has a solution, it can be solved by using square roots. Let's just give it a try right off the bat. Example 1. Solve each equation and verify the solution. Part A. 3x squared minus 7 equals 8. Let's solve by using our square roots by inversing our square there. First we need to isolate the x squared, so we get 3x squared equals 15. Dividing by 3, we get x squared equals 5. Now square rooting both sides here, we get x equals the plus or minus square root 5. Very important that we include the plus or minus. Hence our roots here are going to be x equals square root 5 and x equals negative square root 5. So when we are verifying our solution, we test both. X equals square root 5 comes out to 3 times square root 5 squared minus 7 equals 8. We get 3 times 5 minus 7 equals 8. And 15 minus 7 equals 8, and 8 does equal 8. X equals square root 5 is a good solution. And x equals negative root 5, we get 3 times negative root 5 squared minus 7 equals 8. 3 times 5 minus 7 equals 8. 15 minus 7 equals 8, and 8 does equal 8 yet again. Perfect. Then x equals negative 5 is also a real root. Using square roots. Try it once more. Right? We have x plus 3 all squared equals 20. Well, right away we can inverse our square by square rooting both sides of the equation here. So we get x plus 3 equals plus or minus the square root of 20. But we want the solution to x, so we get x equals negative 3 plus or minus root 20 as our solutions. So we have x equals negative 3 plus root 20, or x equals negative 3 minus root 20. Verifying our solution, we get minus 3 plus root 20 plus 3 all squared equals 20. 20 does equal 20 there. So x equals minus 3 plus root 20 is a real root. And minus 3 minus root 20 plus 3 all squared equals 20. And 20 does equal 20 there as well. So both our solutions here are real roots. Alright, moving on. Not all quadratic equations have roots that are real numbers. For example, 4x squared plus 24. So if we isolate 4x squared, we find negative 24. Dividing both sides by 4, we get x squared equals negative 6. Now here's the problem. When we try to inverse our square by square rooting both sides, we find square root of a negative, which is not possible solution. We cannot square root a negative. So this equation has no solution. Hence, when x is a real number, x squared cannot be negative. So this equation has no real solution. We say that the equation has no real roots. Now, any quadratic equation that can be expressed in the form x plus p all squared equals q, where q is greater than or equal to 0, can be solved by taking the square root to write a quadratic equation in this form. X plus a all squared equals x squared plus 2ax plus a squared. This process is called completing the square. For example, we have x squared plus 6x equals 16. In completing this square, there are a few steps that we need to take. So our first step is to ensure that our leading coefficient of x squared is the constant 1. And in this case, we already have that, so that's all right. So we can leave that as x squared plus 6x equals 16. Our second step is to move any constants on the left-hand side of the equation to the right-hand side. But in this case, we already have it on the right-hand side with our 16, so we can leave it still as x squared plus 6x equals 16. Now this is when it gets a little tricky. Step 3, we're going to complete the square. And we do that by dividing our b coefficient here of 6 by 2 and then squaring it. And here we get 6 divided by 2 is 3, 3 squared is 9. And once we find that constant, we have to add to both sides of the equation. So we get x squared plus 6x plus 9 equals 16 plus 9. Our new equation here. So you'll notice now that we have a quadratic equation on our left-hand side that can be factored perfectly to a perfect square binomial, which is x plus 3 all squared. And when we add 16 plus 9 on the right-hand side, we get 25. Now from this point, we could go ahead and solve using square roots, just like we have been already. So we inverse our square, and we get x plus 3 equals, that is a perfect square, so it comes out to plus or minus 5. And then x equals negative 3 plus or minus 5. So we have a solution of x equaling 2 and a solution of x equaling negative 8. And that is how we solve using completing the square. Let's do some more examples for practice. So example 2 wants us to solve x squared plus 4x minus 3 equals 0 by completing the square. So let's do our steps. We have x squared plus 4x minus 3 equaling 0. Our leading coefficient is already 1. So now let's move our constant to the other side of the equation, and we get x squared plus 4x equals 3. Now we have to complete the square by taking 4, dividing it by 2, and squaring it, and we get 4 divided by 2 is 2, 2 squared is 4. Adding it to both sides of the equation, we get x squared plus 4x plus 4 equals 3 plus 4. This equation factors to a perfect square of x plus 2 all squared equaling 3 plus 4 is 7. Inversing our square, we square root both sides of the equation and we find x plus 2 equals plus or minus the square root of 7. Solving for x, we get x equals negative 2 plus or minus root 7. So our solutions are x equals negative 2 minus root 7, or x equals negative 2 plus root 7. So like I've already been saying, when the coefficient of the x squared term in a quadratic is not 1, divide the equation by the coefficient. I've already expressed how important this is before, but we haven't seen a question where we've had to manipulate the coefficients yet, so let's try that with example 3. Solve the equation by completing the square. So our leading coefficient is 1/2 and not 1. To have a coefficient of 1, we need to multiply by 2 to the entire equation. X squared plus 6x minus 9 equals 0. And our next step by solving by completing the square, we need to move our constant to the right-hand side of the equation. We have x squared plus 6x equals 9. And then we have to complete the square by going our 6 divided by 2 squared, which equals 3 squared is 9. Adding that to both sides of the equation, we get x squared plus 6x plus 9 equals 9 plus 9. And this becomes a perfect square factor of x plus 3 all squared equaling 9 plus 9 is 18. Now we need to inverse our square by square rooting both sides of the equation, and we get x plus 3 equals plus or minus the square root of 18. Solving for x, we get x equals negative 3 plus or minus the square root of 18. So our final answers are x equals -3 plus square root 18, or x equals -3 minus square root 18. Let's give it a shot at a word problem here. Example 4. A person stands on a cliff that is 55 meters high. He throws a stone up in the air. The stone hits the water a few seconds later. The approximate height of the stone is h meters above the water after t seconds. Is modeled by this formula. H equals 55 plus 30t minus 5t squared. When will the stone hit the water? Give the answer to the nearest tenth of a second. First things first, the stone's going to hit the water at a height 8 equals 0, right? So we can rewrite our equation here as 0 equals 55 plus 30t minus 5t squared, which is a quadratic equation like what we've already been working with. So we know how to solve this. First of all, let's rewrite this equation so our leading coefficient attached to our square is positive. Like so. 5t squared minus 30t minus 55 equals 0. There we go. And before we move on even further, we can factor out a 5 here. And then we get t squared minus 6t minus 11 equals 0 now. But this equation cannot factor. There are no two numbers that multiply to 11 and subtract to 6. So let's use completing the square to solve this. T squared minus 6t equals 11 now. Complete the square, we get -6 divided by 2 all squared equals 9. So we rewrite t squared minus 6t plus 9 equals 11 plus 9. And that has a perfect square factor of x minus 3 all squared here. And 11 plus 9 is 20. Solving, we need to inverse our square, and we get x minus 3 equals plus or minus the square root of 20. Solving for x, x equals 3 plus or minus the square root of 20. And hence x equals 3 plus square root 20, or x equals 3 minus square root 20. If we use this solution, however, we're going to get a negative value. And we cannot have a negative time amount, so we're just going to veto that one out right away. So solving, we get x equals 3 plus square root 20, which equals 7.47213, etc. And to the nearest tenth, x is approximately 7.5 seconds. So the stone hits the water approximately 7.5 seconds after being thrown.